You have 1 more minute to complete the quiz. Kindly finish it as possible. So the time is over. Kindly submit the Google form. Is my screen visible? Kindly reply. Okay. So before we move on to the today's session, let me inform you that there will be another quiz by the end of the session, and you will all need to complete that also. So I hope my screen is visible, right? Hello. Okay. So, so today we'll be dealing with strip footing or T-beam BBS. And we've already gone through slab and beam BBS. And here the T-beam BBS is basically a combination of both slab and beam BBS. So first of all, let us look onto the data provided by the structural team, which is shown the screen now. So first of all, in this layout, which is the foundation layout, what these red type of rectangles denote is the column detailing, which is the number of columns and the detailing or type of columns that is located in each and every location. And this white lines denote the area over which the T-beam passes over the layout. That is, apart from the plinth beam, which is denoted by the dim lines, which is passing below it. So and we also have three different type of sections denoted by section 11, 22, and 33. So moving on to the section in detail, we get to know that in all of these sections, the hatch design is different. While in the case of section 1.1, we don't have any hatch design at all. While in the case of 2 and 3, we have two different type of hatch design. So we get to know what it in detail using this sectional drawing of section 1, 2, and 3. So here, what these three type of hash design denotes is three different types of beams. That is beam B1, B2, and B3. B1 is basically denoted by providing just the plinth beam and no hash design. And when the case of beam B2 and B3, we are provided with two different types of hash designs. And this portion gives the dimension of beam B1, B2, and B3, and these drawings gives us a sectional detailing of all of these beams. Even though the dimensions of both B1 and B2 are one and the same, that is 200 by 300, we can see that the rebar detailing is different. While in the case of beam B1, we have two number of 16 mm diameter and both top and bottom region, and the stirrups are 8 mm diameter with a center to center spacing of 100 mm. While in the case of beam B2, we have three number of 16 mm diameter in top and three number of 16 mm diameter in bottom, and the stirrup is also 8 mm diameter with a spacing of 100 mm. While in the case of third beam, which is B3, the depth is 500 and the rebars are three number of 16 mm diameter, both top and bottom, and the stirrups are of 8 mm as placed at a distance of 100 mm center to center. So moving on to the sectional detailing of all of these sections, that is 1, 2, and 3, which represents a T-beam area, we have this figure. So in this figure, as the section represents, in section 1.1, we have beam B1, in section B2, in section 2, we have beam B2, and in section 3, we have beam B3. So since the detailing of the beams are already provided here below, what this picture actually denotes is the shape and structure or the detailing of a T-beam. So when we look onto the section 1.1, we can see that the T-beam is basically a combination of a beam as well as a slab at the bottom. And the T-beam rests over a PCC layer. Like this hash denotes, it represents a PCC layer. And the PCC layer is of 100 mm thick, and the base layer has a width of 800 mm. So over that we have a T-beam with a base width of 600 mm, and the base slab thickness is 150 mm. And the beam provided over this is beam 1. And when we look onto the rebar detailing of the base slab of the T-beam, we have two different types of rebars. One is the U-shaped rebar, and the next one is the circular rebar, which is passing over the entire length horizontally over this entire length of the beam. So the U-shaped bar is denoted as 10 at 150 mm center to center spacing. So this basically a 10 mm rebar, and the circular rebars is denoted as 10 at 200 mm spacing. So similar to this section 1, we have section 2.2 and section 3.3. The only difference is the change in beam. That is, in section 2.2 we have beam B2, and in section 3.3 we have beam B3. Apart from that, the rebar detailing of the base slab is one and the same for all of these three sections. So once we understood the detailing of all of these sections, we can move on to the BBS part. So for like we already discussed that the T-beam is basically a combination of beam and slab. So we'll be doing it in two different parts. One for the beam BBS, which is or the beam that is passing over the entire length, and the second part is for the slab BBS, and the slab here denotes the base slab of the T-beam. So first of all, we should take two copies of this image, that is two copies of this foundation layout. One for beam BBS and the second one is for slab BBS. First of all, let us move to the slab BBS. So in slab BBS, what we are actually dealing with is that the base slab of T-beam. So we should only take care of the base slab. So we can delete the beams as shown here in this figure, and later we get a figure containing only the slab. So in this drawing, the set of rebars which will be denoting is only the U-shaped bar. That is that is in this base slab of the T-beam. Apart from this two type of rebars, that is the circular one and the U-shaped one, in this figure we will be only dealing with the U-shaped one, that is having a detailing of 10 at 150 mm center to spacing. For since the detailing for this U-shaped bar is same for all of these sections, that is 10 at 150, we'll be needing it only in a single image. That is as shown here. We'll be placing a copy of the image having only the base slab of the T-beam, and in this we'll be drafting the U-shaped bar. And while drafting the U-shaped bar, some of the factors which we should take care of is that the cover. So basically, since it is a structure which is in contact with the ground, this cover which will be provided is actually greater from that of the slab, which is provided normally in the superstructure area. Normally in slabs, we will be providing a cover of 25 mm, but in this type of structures, which is in contact with ground, since it is a part of foundation, it will be directly in contact with ground. Hence, we'll be needing to provide a greater cover, that is over 40 mm. So once we provide a cover of 40 mm, we can then draft the U-shaped bar we're using the layer called SRC slab board bar, since it represents a slab portion like we already discussed in slab BBS session. We should provide the layer of this rebar as SRC slab board bar. And once we draw the U-shaped bar, we'll be denoting it using a dimension layer, that is shown as here. And the dimension layer is usually provided over the point from the start point to end point over which this U-shaped bar should be aligned. So when we move to this figure, we can see that over this entire length, the T-beam is present, and hence we can represent this U-shaped bar using the dimension layer starting from this point to this point. Similarly, we should also provide U-shaped bar over the entire figure along which the U-shaped bar continues as shown in this figure. So once we provide the dimension layer, we should denote it as 10 at 150, which is as per the structural requirement. That is as per the structural requirement provided in the sectional drawing, that is 10 at 150. Once we draw the dimension layer, we should need to connect the dimension layer with the rebar that is actually denoting by this dimension layer, and it will be connected using a node. That is, a node is connected that is, a node is provided to connect the rebar with the dimension layer provided. Similarly, we should continue to provide a dimension layer and node for each and every U-shaped bar which we provide. Once we completed the drafting part, we should take a copy of this image. We should take a copy of this drafted copy, and we can scan it using aadspro. Like we discussed earlier in slab BBS, the procedure is one and the same. That is, in once we open the aadspro, we can just scan the slab, and once we complete the scanning, we can import the scanned table into the AutoCAD using the export option. So here, since the rebars are one and the same, that is 10 at 150 mm center to spacing, we'll be having only a single row since the entire rebars are same. And here in this table, we'll be having the figure or the image over which the rebars had to be bended, and the number of bars, the total length of each rebars, and so on. So by that, we completed the slab portion. Later, we can move on to the beam portion of the T-beam area. So for that, we take a copy of this layout as well, like shown on the screen. So once we take a copy, we can see that here the beam numbers or detailing is not provided. That is, even though we are provided with a beam B1, B2, and B3, we are not given any idea of what these beams actually represent. So for us to understand, we can actually give each and every beams a name. That is, if this beam denotes B1, we can give it as B1. And since there are plenty number of B1 beams, we can give an additional number, that is 1, 2, and so on. So first of all, to start, let us look onto this beam. So here we are seeing a combination of beam B1 and B2. So for that, let us identify which of this beam represent. That is, in this figure, we can see that beam B1 1 and beam B2 1. So this drafted copy which is placed over here actually represents this part of the layout. That is beam B1 and B2 B1. So for doing the BBS, we should actually draft this entire section. So the drafting portion of beam BBS is actually discussed in the previous classes. So I won't be repeating it again and again. So the basic step for drafting is basically placing Excel lines and doing the drafting based upon the requirement, that is the depth of beam. So here we have beam 1 which has a depth of 300 mm, and for the remaining portion we have beam B2 which is also 300 mm, but the rebar portion is a bit different, like we discussed earlier. That is, B1 have two number of 16 mm diameter top and bottom, while beam B2 have three number of 16 mm at top and bottom. So once the drafting part is over, next step is to denote the rebars. So since the T-beam is actually resting over a PCC layer, these columns should not pass below the T-beam, and it should pass only above the T-beam. Hence, we should not draw the columns below the T-beam. So after that, we can draw the rebars by providing a cover of actually 40 mm, like we already discussed earlier. That is, since this structure is in contact with the ground, we'll be providing an increased cover. So that is actually 40 mm. Once the cover is provided, for the entire section, that is in the figure, for the entire section of beam B1, we can provide 2 number of 16, and for the entire section of beam B2, we can provide 3 number of 16 mm diameter bar. So for here, for the entire section, that is from this point to this point, it actually denotes the beam B1, and the second point, that is from this column to this column, it is actually beam B2. So for beam B1, we have 2 number of, that is represented, that is marked over here, that is 2 number of 16 mm diameter. And as we already discussed, the diameter, the layer for the rebars should be SRC reinforced, and it should be marked using a label with with a layer SRC leader. So since it is beam B1, we can mark it as 2 number of 16 mm diameter. So, and for beam B2, we have an additional number of 16 mm diameter, since it has 3 number of 16 mm diameter bar. So we should mark an additional number of 16 mm diameter only for this beam B2. So for that, we should draw an additional number of additional number of 16 mm diameter, like as shown in this figure, and it should be represented as 1 number of 16 mm diameter, and it should only continue in the beam B2 and not to beam B1. But we should not cut this additional 1 number of 16 mm diameter right at the column junction. Since the column and beam junction is a critical point, we should continue this single number of additional rebar, even though it is a part of beam B2, it should continue to a specific distance to beam B1 as shown in this figure, and this additional lapping distance is as per the equation of development length. So the formula for development length, that is the distance for which the rebar should be overlapped to the portion B1, is actually from the development length equation, which will be provided in IS 456 2000 clause 26.2.1. That is the least equation is shown in this clause, and we should provide the distance as per this equation. So likewise, we should provide the additional number of 116 mm diameter in the bottom area also, that is shown in this figure. So uh, moreover, we should also provide a development length to the column that is provided in the above area of the T-beam with a development length of LD, with the development length of this equation. So this additional length of rebar should be provided into the column areas. And since we don't have a column below this T-beam, we can just cut off the rebar after providing a clear cover. So once the beam drafting is completed, we can actually move on to the slab area. So since it is a T-beam, we should also mention the slab portion along with this beam section. So when we move on to this figure, we can see that over the entire region, and that is when we this figure. So over the entire region of beam B2, we have a T-beam going on. And for the beam B1, we don't have a T-beam for more of the portion, but we have a projection of the T-beam slab over some of its areas. So we should mention this in the figure. That is mention this in the beam figure. So for that, we should actually measure this projection, that is from this column to this endpoint, that is we have a distance of 999. And similarly in the other end also, we should measure this using the dimension line, and actually a distance of 200. So both of these projections, that is 200 and 999, should be denoted in this beam drawing. So in this beam drawing, this small projection denotes a 200 mm projection, that is at the one end of beam B2, and the other end of beam B2 we have a 999, a projection of 999, that is shown using this dotted line. I've represented the beam using a dotted line because this portion of the slab is actually present inside this beam. And since this longitudinal section actually cuts the beam along its center, this beam should be represented using a dotted line. And the section and the projection of 100 mm, no, 1000 mm, is actually represented using this dotted line. So once the dotted line is marked, we should draw the rebars of the remaining slab portion. So in the slab portion, that is slab portion of the T-beam. In the first figure, we have actually denoted the U-shaped bar. So the only rebar that is remaining is this type of circular rebars, that is 10 at 200. Only these circular rebars are actually remaining. The remaining U-shaped bars and the beam rebars have been represented in both slab portion and the beam portion. So the final step is to represent the circular rebars, that is 10 at 200. So in order to find the number of rebars, that is the number of 10 mm diameter at a spacing of 200 mm over this entire base slab, we can actually find it using the formula. That is the formula for number of bars, which is length divided by center to center spacing plus 1. So the base width is 600. So 600 divided by 200 plus 1. So when we calculate it using a calculator, we can find a number of rebars as 4. So for this section, we have the number of rebars as 4. So we need to represent that for number of 10 mm rebars in this figure. So in the beam portion, that is in the base slab portion represented over here, we should actually represent the additional number of, that is 4 number of 10 mm diameter. So in order to distinguish these rebars of T-beam base slab with that of the beam, I have represented that rebar with using a different color, which is cyan, but the layer is same, that is SRC reinforced. So by keeping the layer same and by providing it in a different color, we can actually distinguish the rebars of base slab with that of the beam. And similarly, we should provide a development length of a small LD portion over both of these ends, and we can actually denote these type of bars using another set of dimension line, that is for a number of 10 mm diameter, only for this CN type of rebars. That, and it should extend towards the end of the slab as base slab as well. Not only in the beam, it should also extend over the projected area of the slab. And here also we should provide a minimum cover of 40 mm. So once the slab portion is drafted and the dimension line is provided, we actually completed the drafting part. And for each and every beam, we should name the beam as B1 and B2, and we should also provide an additional number to distinguish it from the remaining bars. And in this case, for the beam area, in order to represent the stirrups, that is 8 at 100, that is, in order to represent the stirrups, we should actually provide a line which is of the layer SRC stirrup reinforced, which is over a distance of about 50 mm from the column. So likewise, we should provide a stirrup, a rebar, which distinguish the main bars apart from the stirrups using the layer SRC stirrup reinforced in both ends of the beam. Likewise, we provide the stirrup rebar in each and every beams. And um, for denoting the direction along which, or the portion along which these type of rebars, which is stirrups, continues, we can actually denote it using a dimension like that is shown over here. That is from this point, starting from this point to the other point over which the stirrup ends. That is starting from this point to this point, we can actually provide a dimension layer and mark the stirrup as 8 at 100. Similarly, in this beam B2 also, we have the stirrup detailing as 8 at 100. So we should provide the stirrup detailing as 8 at 100 for this area too. Likewise, we should draft each and every portion of the remaining beams as well by comparing it with the foundation layout, by drawing the Excel lines, and by drafting it using manual drafting. And once the beams are drafted, we should provide the rebars and give proper layer. And once the beam area is completed, we should actually draw the T-beam portion over which the beam progress, and the T-beam should be represented using a projection if it is projecting out from the beam, and the rebars can be distinguished from the remaining rebars using another type of color, but the layer should be same as that of the rebar, that is SRC reinforced. Likewise, once we completed the drafting portion of the entire rebars, of the entire beams, we can actually have a copy of this entire set of beams as shown by the side of this figure. And once we take a copy of this, we can actually move to the aadspro section, and in that we have a scanning option under beam. So once the beams are scanned, and the scanning process and all is already discussed with you in the previous classes, and once it is scanned properly and completely, we can actually import the scanned table into the AutoCAD drawing, which is shown as this. So this is the table which we get after the scanning procedure, and all of these numbers actually represents the each and every rebars mentioned in the drawing, like 201, 202, and all. And all of these rebars actually represents each and every bars that is provided in the table. And by looking onto each and every bar, that is number of, that is the beam having that is the rebar having the number 202, we can have a clear cut idea of the length, the design of its alignment, the number of bars, the length, and so on for each and every bar. Likewise, we can complete the scanning procedure as well. By this, the BBS for T-beam section is completed. That is completed in two parts, that is slab and beam. So, does anyone have any doubt? Hello.